Hey guys, I welcome you all to my channel. This is Anirudh. So in this particular video, we look into some of the questions that I have collected from the topic of Prism, and we'll just understand that. And these are the only type of questions which were asked in the previous year's papers. Okay, so this is the first question that I've taken, and this is pertaining to the exam Neet 2018. So remember, this is a prism. So angle of prism is 30 degree, refractive index is root 2. So this is root 2, right? And one of the faces is silvered. So this is the silvering. Okay, at what angle of incidence a ray should be incident on the surface so that after reflection from the silvered surface, it retraces the path. See, this is acting like a mirror. So this is a silvered surface. That means it will act like a mirror. I mean a plane mirror, because there is no curvature here. It is one of the face of a triangle, a plane mirror. So on a plane mirror, the condition for the ray to retrace the path is when the ray actually falls at an angle of 90 degrees. So the angle of incidence on the plane mirror should be equal to 90 degrees. So how will I do that? If this is my ray, then I'll have to make it fall at an angle of 90 degree with the angle with the plane mirror, right? This particular silver surface. If this is possible, then if this is the direction of the incident ray, then after hitting here, since it is 90 degree, it will come back and it will go in this particular way. So this is the condition. So everything that we have supposed to know is there with us. Angle of the prism is 30 degree. So this is 30 degree. So this is 90 degree. So this particular angle will definitely be 60 degree. I am just using the angle sum property. The total angle is 90 degree because this is normal to the incident surface. So this particular angle will be 30 degree. Fine. So this is our I angle. We are just supposed to find this I angle. I will apply Snell's law across this surface. So that will be 1 sine I is equal to mu, that is root 2 times sine 30 as 1 by 2. So this will cancel out obviously, and that will give us the answer as 1 by root 2. So therefore I is equal to 45 degree. Okay, so the answer for this question is pi by 4. Okay, this is a previously asked question. I did not just take the options. I had solved this video in a separate lecture also. I had just taken 3 questions from different random questions in physics and from different exams, and I just solved it over there. And so this question was there also. Okay, so the answer for this question is pi by 4. This is a very simple question, just requires some bit of geometry, and if the question has this particular diagram, it becomes all the more easier to work out on the paper itself. Okay, let's proceed to the next question. So this question I have taken from 2016 paper, fine, and let's read through this. The angle of incidence of a ray of light at the refracting surface of a prism is 45 degrees. So therefore I is equal to that is angle of incidence is equal to 45 degree, right? Okay. The angle of prism is 60 degrees, so A is also given to be 60 degree. And if the ray suffers minimum deviations of the prism, so condition of minimum deviation is put into picture over here. So we know that what is the condition of minimum deviation? I1 is equal to I2, okay, and also R1 is equal to R2 is equal to A by 2. So definitely the ray is parallel to the base of the prism. So at least remember these 3 points over here. Okay. Now I1 plus I2 minus of A is delta. So delta is equal to 2I minus of A, since I1 is equal to I2. So at least these much points you need to remember so far as the condition of minimum deviation is important. Okay, is concerned. Angle of prism is also given. They are asking us to find the angle of minimum deviation, that is delta min. This is angle of minimum deviation, that is equal to twice of 45 degree, isn't it? 45 minus of 60 degree. So this will be 90 minus 60, that will be obviously 30 degrees, isn't it? So the answer for this one part we have obtained, that is 30 degree. So our answer can be either this or either this. Okay, these are just ruled out over here. Now they are asking us to find out the refractive index. So whenever we have this particular value of delta minimum, we can directly find the refractive index very easily. That is mu is equal to sine of a plus delta by 2 divided by sine of a by 2. Okay, so if you can just substitute it over here, sine of a plus delta is actually angle is 45 degrees, and at 45 plus 30 by 2. Oh, sorry, I'm wrong. So that is actually a plus 60 plus 30 is 90 by 2 divided by sine of a by 2. A is 60 degree by 2. So this is equal to, how much is this? So I think my vision is, my photo is coming over here. So that means video is here over there. So I will just write it over here. Sine 90 by 2, sine 45 is 1 by root 2. Okay. Sine 60 by 2, sine 30 is 1 by 2. So that 2 will go upstairs. So that simply means I will get the answer as root 2. Okay. So the correct answer for this question is option 2. So the answer for this is option 2. Okay. A very simple question, a very neat level question. Okay, you can say that. Let's proceed to the next question. This question is from JEE main. Okay, main paper 2015. This is a 5 years old question paper. You might or may not have seen this question as we are preparing for the Neet exam, but yes, this is a good question, and this only requires whatever we have actually dealt in the discussions of prism, whichever we have done previously. Okay, so monochromatic light is incident on a glass prism of angle A. Angle of prism is given. If the prism refractive index of the metal of prism is mu, a ray incident at an angle theta on the face AB would get transmitted through AC. That means it is going through this, and finally it has to come out. Okay, that is meant by the word transmitted through the face AC for which of the following condition, and we have to find that over here. See, so whenever transmission is done, I can say that R2 should be less than theta C. Okay, that means this is the critical angle for this particular surface. If it is more than the critical angle, then it will undergo total internal reflection into the prism itself. So that means this particular R2, which is the angle over here, this is R2, this is R1. Okay, this is R1 and this is R2. R2 should be less than theta C for it to come out. That is all we are supposed to know from this. Okay, then if that is supposed to be there, let's suppose R2 is equal to theta C, and then we will go for how to put the appropriate greater than or less than sign after that. Let's try to solve this as such. So in the first surface, if I am applying this Snell's law, let's suppose the refractive index of air which is outside is 1. Okay, so 1 sine theta is equal to mu. What is mu? Okay, mu times sine of R1. Okay, so from here, what is R1? R1 is equal to sine inverse 1 by mu sine theta. Fine. So R2 is equal to, that means R2 is equal to A minus of R1. So that is equal to A minus of sine inverse 1 by mu sine theta. Fine. Now we are supposed to go for the expression here. So R2 is less than theta C. So what I can do is that, what is the theta C over here? Sine theta C is equal to 1 by mu. So theta C is equal to sine inverse of 1 by mu. Fine. Okay. Okay, so theta C is equal to sine inverse of 1 by mu. So our required condition is R2 should be less than theta C, isn't it? So this A minus of sine inverse 1 by mu sine theta should be less than theta C. So theta C is sine inverse of 1 by mu. So from now on, whichever properties we are going to use, it will be based on the inequality which we have learned in mathematics. So actually what happens is, here if I am just using sine theta, so my intention is to keep theta on this side and transfer everything else to the other side. Okay, so we'll do that one by one. Sine inverse of 1 by mu sine theta C. This will be less than sine inverse of 1 by mu minus of A, and I have a negative sign over here. Okay, so this is less than sine inverse of 1 by mu minus of A. So I have to simply take this to the other side. So when I take this particular negative sign to the other side, then this particular value will change definitely. Okay, this is outside the bracket. It's a little bit difficult, but yes, we'll be able to solve this anyway. So sine inverse of 1 by mu sine theta is less than, greater than A minus of sine inverse of 1 by mu. I'm just changing the signs over here. I just took this to the other side, or throughout I multiplied with negative sign, that you can say in that way. Okay, let's proceed with the discussion of this. Now what I will do is that, see, sine inverse is taken to the other side, so that becomes sine of this much. Okay, so there is something called as sine of a minus of sine inverse 1 by mu. Fine. Okay, so sine is gone that way, and this mu is to be transferred here, so mu multiplied by some big value, and now the sine is also taken to the other side, so that will be sine inverse of. Fine. Okay, so this is the value of theta. I mean, theta is actually more than this particular value. So this is the answer for this question. So I will put a big bracket over here, and let's check the options now. So only in the fourth option you can see over here. So I had done this previously. So in the fourth option, theta is more than sine inverse of mu sine of a minus or sine inverse of 1 by mu. So this is the answer for this question. So you can practice this question within, if you try to do this once or twice, then that means you will be able to solve all questions. So whatever is required from this for solving this, I had discussed everything in the greatest detail possible at your level whenever we had a discussion of Prism. Okay, so everything had been discussed in great detail. So I hope there is nothing much to know over here. Just to conclude that this particular sign has to be transferred whenever you are throughout multiplying by negative. Only that particular point you need to understand so far as your mathematics in this question is concerned. So these kind of questions I don't expect it's a big calculation, but yes, in NEET also you will be seeing options in which these kind of things are given. That is true. I don't know how to comment on this, but obviously you can practice these kind of questions from the previous year JEE exams. Which are at your level. So my intention is to give you an overview of these kind of questions which I used to find as good questions when I was preparing some 4 years ago. So in my subsequent videos also I'll be giving you all these kind of questions. So there is no point in keeping everything very simple without understanding the real level of NEET exam and on how to improve the level of physics, that of your level of physics, so that you can complete more questions in a shorter time and attempt more tougher questions also in the NEET exam. So for this year I am not in a position to comment on the difficulty level because everybody is getting a lot of time. And in this particular aspect, if I just think about that, then the competition will obviously be slightly more tougher than it is expected to be, and therefore definitely there will be some kind of difficulty in the paper. If it is coming too easy, then the competition will be so high that even if you get one question wrong, then that will lead to a tremendous decrease in the ranks. But if it is too tough, then it will be much more better on that kind of a scenario. So obviously at this particular moment, my advice to you will be to go for good level questions, understand the level of questions that are asked in the NEET exam very thoroughly. So that is why I always tell my juniors to analyze the paper and then give the exam beforehand. Okay, so do that. So that will give you a clear-cut idea of what kind of questions are coming, and then ask yourself like whether you are actually solving questions of that particular level or your level is low. So you'll have to constantly work to improve that particular aspect of that. Okay, so keep watching my videos in which I will be solving these kind of questions. Whichever I find striking in my mind, then I will definitely give you all those kind of questions in these kind of videos, like the one I have given you in this question. Let's proceed to further questions now. So friends, this is a good question. A light ray is incident on the face AB. So this is the AB, fine, and this is C. This was also given in the question. And the refractive index of the prism, material of the prism is 3/2. What is the largest angle theta for which the light ray is totally reflected at the surface AC? So this is the AC, it has to be reflected. So for that to happen, then you can say that this particular, so if I am just drawing this particular perpendicular normal to this particular surface, this is the angle, isn't it? This angle is actually equal to more than theta c. For total internal reflection to occur over the surface AC, then this particular angle should be more than theta c. Basic concept of ray optics. See, for that matter, let me just construct something over here. I'm just drawing this particular perpendicular to this particular surface from this particular point of entry. I'm just making a perpendicular line. This is theta, this is 90 degree obviously, so this is obviously 90 minus of theta. Okay, So if this is 90 minus of theta and the total angle is 90 degrees, this is the normal to this particular surface. So this whole angle is 90 degree, whole angle is 90 degree. Out of this much is 90 minus theta. So this is equal to theta. Okay. Now this is actually at a 90 degree angle to this particular ray. So definitely I can say that this is equal to 90 minus theta. Okay. If this is theta, then that is 90 minus theta. Fine. So what is theta c for here? Theta c is equal to sine inverse of 1 by mu. So that is equal to sine inverse of 1 by mu is 2 by 3 here. Okay. For this particular surface. This is the critical angle for this particular surface. Critical angle has a standard equation, sine inverse of 1 by mu, and I am just applying this particular value with this. Okay. So that is sine inverse of 2 by 3. Fine. So the point is 90 minus of theta should be actually more than sine inverse of 2 by 3. Okay. So I can say theta is less than 90 minus of sine inverse of 2 by 3. So the point to remember here is that now we are left with the answer. We have got the answer as such, but to make it into a better answer, remember this particular mathematical expression, sine inverse of theta plus cos inverse of theta is equal to 90 degree. So 90 minus of sine inverse of theta is equal to, theta means here 2 by 3, okay. So theta is less than cos inverse of theta, cos inverse of 2 by 3. Let me give the, okay, so that is it. This expression I have just used over here. A mathematical simplification is required over here, okay, just for the sake of doing that. So theta should be always less than cos inverse of 2 by 3 for the ray to have this kind of a total internal reflection. That means it should be always less than that. So the maximum value of theta is, as I was telling you, theta should be always less than this for less than cos inverse of 2 by 3, less than cos inverse of 2 by 3 for the ray to have a total internal reflection. So the maximum value of theta is obviously 2 by 3. Not 2 by 3, cos inverse of 2 by 3. Okay, so this is the value for theta, for maximum value of theta for which this has to happen. Okay, so the answer for this question is this. Okay, I hope this is a easy question now. It requires a bit of geometry in this particular image, but I found this to be a good question to discuss with you in this particular pattern. Okay, so let's proceed to one more question. I had stopped everything and I was actually editing the video while I thought of another question that I had seen when I was preparing, which is also good. Okay, so I had to redo the whole video again, and I'm recording again for you. So by what angle should the mirror be rotated so that the final image coincides with the initial? Just see this. This is a plane mirror. So we are supposed to rotate this mirror. Okay. Now this is a prism, a right angled prism you can say, and this is your lens. This is the convex lens, and this object is actually at a distance of the focal length from the convex lens. Okay. So it is at a distance of focal length from the convex lens. So you know that as such the rays that are coming out of the object is actually going out here, and that will go into the infinity. So all the rays from infinity will come and focus into the focus. Now rays from the focus will go and diverge into the lens, and then it will go back into the infinity as parallel lines. Okay, so these parallel lines will be going like this, and again from here also I can put it like this, and they will suffer a deviation. So in the question, mu is given to be 1.5, right, and the angle of prism is given to be 4 degrees. So these were also given in the question. Fine, so let's find out the deviation here. Mu minus 1 into a 0.5 multiplied by 4 is equal to 2 degrees. That simply means that these rays are going to suffer, if this was the way by which it was supposed to go, now this is actually going to suffer a deviation of 2 degree from the normal path. So that is the meaning of deviation, right? So this is going to suffer a deviation like this. So this angle is 2 degrees. This is the deviation of the ray from the normal surface. If it was supposed to go in the same straight line, if there was no prism, it will simply go in that way. Due to the prism, it is actually having a deflection. That deviation is actually 2 degrees over here, and it is actually arising in this particular area, and it goes like this. So this particular angle is also 2 degrees. Simply alternate angles. It looks like a Z, doesn't it? It is the alternate. These are the alternate angles. 2 degrees itself. Now, correct me if I am wrong. I am going to tilt this particular mirror. Okay, I am going to tilt this mirror in this direction. So I am going to tilt the mirror in this direction of 2 degrees. Okay, I am just tilting this mirror of 2 degrees. So that means this particular light will again, that particular light is actually again coming to this particular normal. So this normal will now come and lie over there. So if I am rotating it to 2 degrees, then this particular perpendicular line which you call by the name of normal will again rotate by 2 degrees, and that will lie along this particular ray. Now the ray is actually hitting the mirror along the normal. Now when I rotate it, the normal goes to this particular surface. I am rotating it to 2 degrees, the normal goes to this surface and it is coinciding with the ray. That means the ray is actually coming now at an angle of 2 degrees. I mean at an angle of 90 degrees with the prism. That means it is actually coinciding with the normal if I am rotating it with 2 degrees. And then when it coincides with the normal, it is at an angle of 90 degrees to the mirror. So it will again retrace the path. Once it retraces the path, the rest it will take care of. Okay, this will go here and it will finally come and lie over here. So the answer for this question is 2 degrees. Okay, so it didn't have much calculation to do here. It required a bit of analysis of this particular image which is given in the question. So this is a good question. It requires a bit of analysis and that's it. Some geometry, some very few calculation to do, and the rest is all analysis. Right, so this was something that I never wanted to leave without discussing it with you. This was a good question. I had seen this in a book also. Okay, so with that, let's proceed to the next question. And this particular prism has a very low angle, so very low A you can say. So that means you can simply use the equation mu minus 1 into A. This is equal to delta. Fine, this approximation can be done. You can simply use this equation. So mu minus 1, 1.5 minus 1 is 0.5, that is half. Multiplied by A is 4 and that is equal to delta. So that implies delta is equal to 2 degrees. Fine. So the deviation suffered by this particular ray of light is 2 degrees. So the answer for this question is 2 degrees. So I hope almost okay. So with that we are coming up to the end of this particular lecture. I think I have touched upon every aspect of Prism that is required for you to crack the NEET exam. Okay. So I don't think any question will be out of the scope of a person who has attended these lectures. And the pattern of the repetition in this question when I have seen this is that every 2 years or 3 years it will repeat. Okay, every alternate year, especially every alternate year it will repeat in the JEE exam or NEET exam. Okay, so yeah, with that we can come to the end of this particular lecture. So if you like this, please like, share and subscribe to my channel. Click the bell icon to receive notifications whenever I upload a video on YouTube. Okay, thank you.